This meeting is being recorded.
Welcome, everyone. I'm Amanda Marlin. I'm the Executive Director at EOS Eco Energy, and we're hosting this talk this afternoon on groundwater protection. I want to take a moment to respectfully acknowledge that our work here at EOS Eco Energy is done on the traditional and unceded lands and waters of the Mi'kmaq. Today's speaker is Justin Liefer. Justin is from Michigan, and he has a PhD in marine sciences from the University of South Alabama, and a postdoctoral research at the University of Alabama as well. He's worked as a research biologist with the US FDA and the Gulf Coast Seafood Lab. He's also worked on the Gulf of Mexico coast in Alabama for 9 years. And he's been here at Mount A since 2014. He was a postdoctoral researcher at Mount A for a few years and then has become part-time faculty in biology and environmental sciences department. He's now an assistant professor in the biology department since the fall of 2019, and he's published research on a variety of topics, such as coastal ecosystems, including effects on groundwater release, so I'm sure we'll hear more about that today, harmful toxic algal blooms and their contamination of seafood, ecology of phytoplankton and other aquatic microbes. And some of the courses that he teaches at Mount A have included field ecology, invertebrate biology, oceanography, marine biology, and ecotoxicology. Before I turn things over to Justin, I just want to remind everybody again to stay muted, just so that we can hear Justin clearly. We'll keep questions until certain times throughout the presentation. So Justin's going to take some breaks to gather or to get questions. So if you like, you can write them in the chat box as you think of them, and then I'll relay them to Justin when the times come. If you're listening today from your phone, then we'll give you a chance to ask questions as well. So thank you so much, Justin, and I'll turn things over to you now.
Hi there, folks. Thank you so much for that wonderful introduction, Amanda. As Amanda said, I'm a biology professor at Mount Allison, and I am not a hydrologist or a groundwater scientist per se. I know it's a terrible way to start out an expert webinar, but I have done a lot of research that involves groundwater, and I have worked with a lot of people who are experts in groundwater. So I've had to learn about these tools and learn about a lot of different techniques that we use to study groundwater over the years as well. So in science, we like to make sure we advertise what our true expertise are. And I should say my expertise is more in what the effects of groundwater are once they hit surface waters, which is unfortunately something that does not get studied very much because groundwater is difficult to measure. So I scaled back a lot of what I was going to go over today because I want to try to keep this more open for the sake of questions. And I realized I was preparing to give you guys like a 45-minute lecture like I do for my job on a regular basis. And that's not exactly what I think we needed right now. So let me go ahead and start my presentation, and I'll give you a little intro as to what we're going to do today. Just one moment, it'll take a minute to pop up here. Sorry, one moment. There we go. Should be showing up for everyone now. Can everyone see the beginning of my slideshow here?
Yep, we see your PowerPoint. Perfect.
Okay. So I'll give you a little sense of what we're going to do today. First thing I want to say is explain a bit about my expertise. I don't usually this is just my lab logo. I don't usually like throwing up words in a presentation that people don't necessarily are familiar with, but this is just a nice picture that kind of sums up what kind of scientist I am and what I do in my lab at Mount Allison. Amanda already mentioned the types of courses I teach in marine biology and in ecotoxicology and things like that. But generally, my research interests are in how things that happen at this level of cells and microbes scale up to effects on the ecology of water and aquatic ecosystems like lakes and the ocean, and then also how that affects the chemistry and ecosystem processes at really large scale, all the way up to the global scale. So if you can guess that maybe I have focus issues, you would probably be right. That's where my expertise has led me over the years. And I also want to go ahead and start with something light with a video. What you're seeing here is a clear kayak going over what was very muddy water and then entered into all of a sudden very clear water in an inland area, which is pretty unusual. And we see a lovely manatee here. This is of course not from New Brunswick. This is in Florida in the Homosassa Springs. Also, it's just a cheap excuse for me to start off with cute animal videos, which is always a win. But if you're wondering what you're looking at there, that was an area where groundwater is coming to the surface. And I show you this because groundwater is something that we often don't see and don't think about. And this is a wonderful example of its uniqueness compared to the usual surface water that we see and the cool things that happen when it pops up to the surface. So in these areas, what you're looking at there with these manatees, this is another image of this from a place called Crystal River, Florida. There are places where groundwater can naturally come up in such large amounts near the ocean that the manatees that need to drink fresh water will come to these areas. The water is cooler there, it's fresh. You can also see that usually water that's by these muddy banks, you'd expect to be pretty cloudy, but this water is actually extremely clear. So you're seeing how different this would be from natural surface waters that we typically expect in this area. So just a wonderful example of how unique groundwater is compared to what we see on the surface. And I should also say, if we're going to talk about this today, why should we care? As much as this might seem obvious to folks, it's always worth highlighting these things every time we talk about any environmental issue. First off, why we care about groundwater, it's important to understand what we actually mean by groundwater. And if there's one thing I hope people take away from this talk, it's not imagining groundwater as a pool of water in a cave underground that we tap into. Groundwater is just wet dirt, essentially, right? It is water that is held in soil or spaces in rock. And if there's enough of it that is collected by gravity and sitting on top of something that it can't sink through, it'll pool up enough that we can tap into it with a well. And we'll just talk a little bit more about that as I go forward. Another important reason why we should care about groundwater, and this is actually a number that blows my mind when we think about it, is that 98% of Earth's available fresh water. Now, I knew it'd be more than surface fresh water, but I didn't think it's necessarily available fresh water. 98% of our available fresh water is in groundwater. And that stands to reason that we get a lot of use out of that groundwater with that abundance. 1/3 of all of our drinking water supplies in Canada come from groundwater. And this kind of hints at something I'll mention later and like to discuss with folks later, is that our reliance on groundwater definitely has a rural-urban divide. So 80% of the supply of drinking water in rural Canada comes from groundwater. Much more reliance on groundwater rather than surface water or water treatment facilities compared to urban areas. And also, just the way rivers flow to the sea, groundwater also flows into streams, lakes, and oceans. This might be something we take for granted. But again, just like having people understand that groundwater isn't just water that's in a big hole in the ground, but it's really just saturated soil. This is the other big thing I'd like people to take away in terms of a general understanding of how groundwater works, is that groundwater moves and it flows. It flows horizontally across the land. It's not just something that goes down into a well and then sits there and then we tap into that well. It moves sideways across the earth as well. And when it does that, it also carries our contaminants with it. Right? Okay. So there we go. Almost gave away my joke. So that's why I can generally say groundwater is important, right? But what I want to ask is, why do you care about groundwater? As those in the audience, why are you here? Not meaning an existential question, but why did you come to this today? Why did you choose to use your lunch break to spend time with me, particularly if you're a student who already has me in a class? That's shocking. And I want to know, what do you want to learn about groundwater? Because I basically had a lot of plans and a detailed outline of things that I could cover, but I also wanted to set this up to be meandering and allow people to ask questions and guide what we talk about. Because that's what this is about, is folks learning. Not necessarily me telling you what I think you should learn, but you learning what you want to learn. And also, what are your local or global concerns about groundwater? So some people might be here out of curiosity, might be here because most of the reasons why we're inspired to take interest in environmental issues is usually because of something personal, or something that we've seen lost or damaged around us, or something that we're concerned about losing. Some resource or clean habitat or something like that. So I want to go ahead and just stop here and open it up to the group to have people just share with me what you're interested in about groundwater, why you came here today, what are your concerns for this? Because again, I think that's a key goal of having a webinar like this, especially something that's hosted graciously by EOS, is in order to teach people, we also need to know what they want to learn. So yeah, so feel free to share in the chat window, and Amanda's going to help me kind of look at what's going on in the chat window.
So just as people are writing, I'll start it off and say I'm definitely interested in the flow of contaminants, sort of how groundwater moves, and how we can protect it as well. So that's a couple things to get going. Liza is also saying, oh, curious about the quality of groundwater and monitoring in the Tantramar region.
So I can answer, that's a more specific one that I can answer and address. And again, I won't like necessarily answer everybody's questions now, but I'll use that to inform what we talk about going forward as I kind of give some background information. And I can say that, like so many things, and Amanda can speak to this even better than me, there's always a shocking lack of environmental monitoring in general in our region. And that's not just due to, delinquency on anyone's part necessarily. It's that we have a very big area with a lot of aquatic resources and not a ton of people and not a ton of resources. So much of the monitoring that we do to understand the quality of groundwater is done by periodic academic studies, people taking part in residential well monitoring programs, and the efforts of groups like EOS and folks that are in the environmental nonprofit community doing work, and the support they receive from provincial folks like the Environmental Trust Fund. So let's see what other kind of issues we have popping up here.
Yeah, there's lots of them. Do you want me to go through them, or you're reading them?
Sure. Yeah, I was seeing that. I see a lot of great stuff. It's touching on a lot of things that I expected to talk about, but it's also nice for everyone else to be able to see what the concerns are. So I see some things about the effect of climate change, for example, which is something that we'll mention. There is concern. I wasn't sure if there would be, but as I did my homework for this talk, there is concern about the effects of sea level rise on our groundwater resources. As some of you may imagine, you may have heard of something called saltwater intrusion, and we'll talk about that a bit. I hear other questions. See, Dave has a great question about quarry blasting on groundwater source drinking water. So when I show some images of how groundwater flows, I can talk about some of the effects of that. And I can say that a lot of our underground activities for industrial purposes is something that is a big interest in the area that other researchers are definitely looking into. And I can speak to that a little bit as well. Anything else that sticks out to you, Amanda, to highlight? I see folks here out of curiosity. That's wonderful.
Yeah, and questions about how quickly does it recharge? I think that's a really interesting one too.
Say that again.
How quickly does our groundwater recharge?
That depends. Highly variable, but we'll talk about that a bit more.
Okay.
So let me move on. Let's go ahead. This is great. That helps me think. But well, I did have a lecture planned. So I mean, I guess your questions they're all just rhetorical. I'm kidding, of course. But just to give you an idea of what I'd like to do with our time, like I said, this is not a lecture. It's meant to be me addressing questions and giving some background for folks who might not have much familiarity with hydrology. So I'll give you some background, some groundwater 101, and then we can talk about concerns for groundwater quality. What are some specific local concerns? And I'll mention some things that are more in my wheelhouse and area of expertise. Like I said, in preparing for this, I did my homework. If any of my students know, I hate being stumped with questions. I don't expect myself to know everything ever. I love wallowing in my ignorance, but if I get asked a question I don't know, I obsessively have to go find the answer. So I kind of anticipated that and tried to brush up on a lot of the local issues and local research in the area. So I stand ready to be a good funnel for that. And like I said, then we can talk about some action items, some important things to mention that you can do as individuals, or we can do as communities about groundwater preservation, and then have some more discussion and questions with the time that's left. So, oops, there we go. Sorry, I keep double skipping slides. So first off, if we're going to talk about groundwater and what groundwater is, it's worth mentioning what an aquifer is. So an aquifer is just the location where we keep one mass of groundwater, or one piece of groundwater, an area of water that has all similar features, right? It might have similar temperature, some similar chemical conditions, and it's all kept at a similar location. And we also call something an aquifer, an area of groundwater. What makes it an aquifer is that it's connected, that it's groundwater that talks to each other, essentially. And when we're talking about aquifers, it's important to understand that they come in layers, that we always have pretty much everywhere, unless you're on rock solid bedrock on a mountain. There is some superficial aquifer, as we call it, or generally what we commonly refer to as the water table, where water can seep into the earth and it will accumulate and sit on top of something that water cannot soak through. We call it confining unit, or a confining layer, or an aquitard. Those are all the names for it. But basically, it's a layer of rock or clay that water does not seep through very easily. So we always have water sitting at the surface at a certain level below ground in the surface level. But water can seep through those confining layers really slowly and accumulate over time, or be trapped due to other geological formations and things like that in these deeper aquifers that are below the superficial one. So this is why if you've ever had a well drilled at your home or something like that, someone might start drilling, and then they look to see if they get water, and they get water and it's not good. And then they drill a little farther and they get nothing. And then they drill even further, and then there's good water. Because this is generally what it looks like if you drill into the ground. Because at the beginning, when you're drilling shallow, you're getting into just this shallow groundwater. That is the newest groundwater. It's stuff that's very recently put into the ground and seeped down from the surface. And then you go through layers where there's not going to be very much water, that's water pressure that's going to be able to go into a well. And then you can get into one of these trapped lower aquifers. And those lower aquifers, again, just to give some terminology that you'll hear and throw out when if you look into this, or if you look into your own water, that's what we call a confined aquifer. So basically an aquifer that's not sealed by the land surface, but sealed by some other layer is a confined aquifer. It's also called an artisanal well or an artisan well. So if you've heard of, artesian spring water and things like that, that's what we're talking about. We're talking about water that's from one of those layers trapped deeper in groundwater. And again, I throw out another picture, another diagram like that, like I just showed you, because that one kind of defeated what I said was one of the goals of this talk, which is you not thinking that groundwater is in some magical hole underground. Again, we're talking about wet dirt and rocks. So water will seep down by gravity through the soil, and it will collect in areas where it can't seep any further, because there is some kind of rock material usually that's not water permeable, that water can't go through. Imagine it's like a slab of cement there underground or something like that. So we have water sinking to that level of the water of where it can no longer sink any further. And then the more we add to it, or if we add to that water table, faster than that water can flow downhill towards lakes, rivers, and the oceans, then that water table will just keep rising and going up. We can also get things that we call perched aquifers, which are or perched water tables, which you can see in these little small images there in this diagram. So if water seeps into an area and it hits something that's impermeable and it can't really move very easily side to side, we can get little trapped pockets of water like that. So this is a good view. This is something that I think is a lot of people don't think about and don't see when they think about their own home groundwater well, that it exists in these layers, and that we have certain layers that are not permeable to water that separate aquifers in this vertical structure. So if we're talking about groundwater, it's also important to say how we get groundwater, how it's made, where it comes from. So this is, I tried to find the most crude, cartoonish picture that you would have seen from 6th grade, like of the water cycle, to say this is true. But then we'll show the more complicated picture next. But as most of us are generally familiar with, either just through living on this earth or remember from basic science classes, that water on our planet is cycled by being evaporated from lakes and the oceans due to the sun's heat, and then it can churn into precipitation like rain or snowfall, land on the ground, melt, and then it makes its way by gravity eventually back down towards the ocean. One thing that we often don't think about is a large amount of that water flow in that cycle is through the ground, right? Groundwater is not just a storage location. It's a place of flow towards stream beds, towards lakes, towards the ocean. But of course, like everything in nature, it's complicated. So when we're talking about how groundwater actually ends up where it is, we're talking about the process of infiltration. So infiltration is our fancy word for how water actually seeps through the ground and arrives in an aquifer. So we have locations wherever that groundwater can make it to, based on what's blocking it below and where gravity takes it to. If the ground intercepts that spot, we have a spring, or we have a lake, or we have a river. We have an area where that groundwater is going to come up. And there's a lot of different paths that groundwater can take through that. So it can come up in small springs. If a river is deep enough that it passes through the water table in some area, or if there's some break in a layer that holds deeper groundwater down, it'll come up into a river or a lake. And also, our continents are much higher than the ocean, than the sea floor. That kind of stands to reason, right? So we have a slope on the side of land where land meets the sea. So the water in our aquifers wants to flow by gravity out to the ocean. And it's going to do that either through rivers or through the ground and release into the ocean, what we call submarine groundwater discharge. So overall, this process of water coming down from the surface into groundwater is recharge, right? And so it's important to just, again, I don't want to just give everybody lots of terminology, but the jargon is important when you look up things and look up resources so that you can speak the language of this. So infiltration is the process of groundwater seeping down. Recharge is the process of an aquifer being refilled, of being brought back up to a certain level. And like I mentioned in talking about why we care about groundwater, it's important to note that we don't just send water down through soil. That water carries things. And our term for that is what we call leachate. So you may have heard talking about things leaching through the ground. So just like if we stick a tea bag into hot water, right? There are dissolved things that will come out of that tea and give us caffeine and the power to attack the day. And also lots of other wonderful things and flavors, things like that. This happens with everything, all other plant material on the Earth's surface, as well as with whatever horrible things in the vast variety of things we put into landfills. Basically, if something is even slightly soluble in water, it's going to dissolve in precipitation. It's going to be carried down through the soil, into the water table, into groundwater. And there's a lot of differences as to how things behave and travel. And this is something that's important to note. Not all things move equally through groundwater. Some things stick to the soil better than others. Some things dissolve in water but more easily than others. When we think about the whole variety of possible contaminants or things like that that we might be concerned about getting into groundwater, they each have they're each their own special little flower. They each have their own unique properties that's going to shape how easily they dissolve in rainwater and how far they're going to make it in groundwater. So that's another important thing to remember, is that if you live near some area of concern or an area where there's a contaminant of concern, just because you're the same distance from that site as someone else who is by some other polluted site, or just because you live in a similar area with similar soil, doesn't mean that that contaminant by you is going to move towards you just as much or just as fast. The chemical properties of every individual thing affects how fast it can move down through groundwater, into groundwater, and how fast it can move horizontally. So actually, that's a good spot to stop for questions. Does anyone have any questions or comments or anything to share before I move on with a little bit of Groundwater 101? We'll chat. I see a great comment from M about leachate. The folks who grew up in the Moncton area, if you guys can see that. And the issue of landfills is indeed a major concern. We often think about pollution of our lakes and streams and things like that being runoff, being pipes, coming directly to things. But even landfills and areas that are meant to have some kind of sealant at the bottom of them. As you can imagine, fighting any kind of massive process on Earth is usually imperfect, right? It is pretty damn hard to keep water across a huge area from seeping down by the force of gravity. We can lay down things underneath landfills that supposedly seal that landfill, but we do that once and walk away, and gravity is standing there all the time doing its work for eternity. So that's definitely a concern in a lot of areas. That's also the source of many contaminants of concern nowadays, is not necessarily what gets dumped down drains or into the sewage system, but rather what leaks through landfills and areas like that. And it's something that we regulate far less than what we put down drains. See a good comment from Bob. think that's one of our earlier comments as well, but asking about how wells go dry. And I can address that a little bit better when we talking about how groundwater moves and how we interact with the groundwater level. Anything else? Feel free to shout out too. Feel free to turn on your mic when I stop like this as well. Okay. If not, move on. So how does groundwater move? It's hard for me to find a good picture of this without making one myself that sums up what the idea of a hydraulic head is, hydraulic gradient is. But it's a pretty straightforward idea. So I tried to make this as non-mathy as possible. So ignore the equations, but the points that are marked on this image are helpful. So if you want to figure out how likely groundwater is to get from point A to point B on an image like this, you need to know two things. You need to know how high the water table is at point A relative to point B. And you need to know the distance between those 2 points. So it's as simple as that. Those numbers together make what we call a hydraulic gradient. So if we have water seeping down to the water table, but we have areas that are higher elevation, so the thing that's going to stop that groundwater potentially is also up higher. The water table is going to sit at a higher level, and water wants to flow downhill, and it's also going to flow over a distance. And if we know how far it has to go downhill, how far it has to go, that's going to help tell us what exactly is happening. Sorry, I'm trying to move my chat window here. There we go. Okay. But this is also complicated. So it's not as simple as water always just flows downhill. Because if you stop and think about this, the water that is collecting downhill also has more gravity or more water pushing on it from above. So it also has more pressure. Let me show another image that helps talk about that. So if you were to drill into an aquifer at 2 places, like on a hill like this, so the groundwater wants to flow downhill due to gravity. But we also have more pressure in that water that's lower. So if you tap into the ground, so for example, if you drilled where you see drill hole 2, and you got down low to a certain level, and then you looked uphill and you say, hey, someone drilled a well near the same spot and they got water and I'm not getting water and I'm downhill. Or you could see someone above you drilled, it didn't get water. And then you went all the way down to the bottom of the hill, like underneath where you see ground surface, and then drilled a pretty shallow well. And you get a really big gushing well. It all depends what you get when you drill a well. It depends on where the water table is and this hydraulic gradient. If you are downhill of wherever the water table is, if you are lower than the water table and you drill a well into that spot that's lower than the water table, or the water table around you is higher than that spot, water is going to spring up to that well. And if the water table falls below that level of where the well is, the well runs dry, right? So it's also important to remember that we talk about wells running dry and how groundwater moves. Groundwater is moving horizontally, it's being recharged from above. But when we tap a well dry, it's not like we stuck a straw into one little pocket of water and sucked all that water out. In truth, what really happens is the whole level of water in the area is now lower. And there's 2 things that can control whether or not something ends up being lower. The water table ends up being lower. There's 2 ways. There's one way that water gets into it, and that's recharge we talked about. And then the water has to leave that aquifer is the way we lose water from the water table. So that could be flow out to the ocean, flow out to lakes and streams, or what we suck out of it through a well. So It's as simple as that. If you have less rain, if you have less recharge, and the flow out of the aquifer, the losses from that water table don't change, the water table is going to go down. If the rain stays the same, but you take more water out of that aquifer, either by changing how groundwater flows in the land or by drawing more from wells, the water table is going to go down. There's no magical process underneath generally that's going to all of a sudden bring up new groundwater, especially from the aquifers at the surface. Okay, so that's pretty much what I have for groundwater 101 stuff. And I wanted to move into talking about some more local issues. Particularly if folks have questions about saltwater intrusion, I can talk about that as well. So yeah, I'll take another chance for questions here. And again, feel free to shout things out if you have it. Or Amanda, you can also pick anything from the list if you'd like.
I want to pick it all, but I know we only have 20 minutes left too, so I will let others go. And I think Em has another comment here. I think learning about saltwater intrusion would be very interesting for sure, especially in the wake of Hurricane Fiona. Yeah.
Right on. Okay. Give me 1 second here. I had extra slides that were meant for is my screen being shared anymore, or is it just my video?
Yeah, we can't see your screen at the moment.
Okay, good. Let me just switch to the other stuff I have, and I'll talk a little bit about saltwater intrusion. Because that is complicated. And I tried to find the simplest picture I could to help with that. So saltwater intrusion is a major issue in a lot of coastal areas. And in places like what I showed you, where you saw those lovely manatees, like Crystal River, places like that, in Florida, it's a massive problem that gets a lot of attention because basically anywhere where you have land that can easily allow water to move, so what we call porous aquifer or porous earth, the water is going to want to flow downhill towards the ocean. So again, there's a lot going on in this picture, but it's worth sitting here with it so I can explain a lot of what's going on with groundwater flow at the ocean interface. So as I said, kind of in more general terms, groundwater wants to flow downhill towards the ocean. But of course, it is, as with most things in nature, it's not that simple. We have a couple different things going on. One, the level of the ocean changes all the time, especially if you live by somewhere where there's tides, right? It changes twice a day. Also, groundwater levels change over time seasonally, right? And water levels of the sea level change over time seasonally. As we have more precipitation or less, and they also change over really long time scales, like geological time. We also have another thing going on, and that's that salt water from the ocean is more dense than seawater. I mean, it's more dense than fresh water, sorry, groundwater. So whenever we have fresh water flowing out into the ocean, unless it is being actively mixed really aggressively by winds or by waves or some other force, fresh water is always going to sit on top of seawater because it's less dense. Less dense things float on top of more dense things. So what you often have at the place where land meets the sea, below the surface, is that the pressure, water pressure, as you go deeper from the ocean, pushes against an aquifer at the surface. It pushes against that groundwater. And it wins at the bottom side of that aquifer. So when you see in this picture where it says saline groundwater, what's happening is you get this wedge of salt water that forms at the bottom of a coastal aquifer. And again, this is happening because there's water pressure due to gravity from the ocean pushing down into that ground, and water can seep into that ground just like you can see groundwater recharges on the surface. But that seawater is more dense, so it can kind of muscle out the groundwater and push it out of the way. But groundwater also has a flow to it. We're constantly adding to that groundwater through rainfall, through recharge, so it's flowing towards the ocean and essentially making a flow and a push against that wedge of salt water and towards the ocean. And those two things pushing against each other and other processes like waves and tides actually create this constant circulation of water between the groundwater and the ocean. And this really happens on a really rapid scale near the surface, right where like waves break and things like that. So I had a picture there earlier that showed water seeping out of a beach face when I was talking about why we care about groundwater, because it goes out to the ocean. So when you see a beach at high tide, water level goes up with high tide, and that forces water into the beach, into the groundwater there at the surface of that beach. And then as the tide goes out, that water will seep back out. And there's a lot going on in terms of chemistry and biology as well through those processes of seawater being circulated through the land. So that's one big part of what we're talking about, what actually happens between groundwater and the ocean at shorelines. And the same thing happens with these deeper artesian springs, or the confined aquifers, the deeper ones that are beneath some kind of layer, right? Basically, wherever we have a sea floor where water can seep through it, water pressure and the density of seawater will make it force in there and mix with fresh water. And the fresh water is generally is going to always sit on top. The issue with saltwater intrusion is like what I said before. The water table and where the water table is, whether or not you get water from a well from one location, is only based on a few things. It's based on how much water you put in and how much water goes out. So if you are draining more and more water from a groundwater well, as many coastal communities do, that layer of fresh groundwater that you see in this image there at the top is getting lower. In other words, the water table is getting closer and closer to that wedge of salt water that you. On top of that, if the sea level is getting higher and sea level is going up, that makes more water pressure that's pushing on that salt water, that wedge of salt water in the water table. And that wedge is going to get bigger. So if your well is sitting there in the same place, if you're sucking out more water, the water table is going to go down and beneath your well. Or if the ocean level goes up, that wedge of where you see that dark blue saline groundwater is going to get wider and push farther into the earth, farther into land, and be up at a higher elevation. And if that happens enough, because of people draining water, or because of changes in development at a coastline, or because of sea level rise, eventually that layer of saline groundwater, salty water, will raise up high enough that it hits the bottom of your well, and now you're drinking salt water. So this is what we're talking about. We're talking about saltwater intrusion. That wedge of blue is intruding into our groundwater that we want to use. And it happens for two reasons. Either we're removing the pressure of adding groundwater, basically removing the amount of recharge to the groundwater on the coastline, or seawater is pushing harder against it because we've changed the way the shoreline works, or the sea level is going up. So this is something that's going to be a problem in many coastal communities, even if we get a modest amount of sea level rise as we expect over the next century. If the ocean is a meter higher, that's a hell of a lot more water pressure pushing on these coastal aquifers. There's already areas where this is a concern. There's places like, there's some studies that were done near Wolfville, and those parts of Nova Scotia and those parts of like near the coastal Bay of Fundy were not expected to be a concern for saltwater intrusion, but it turns out a lot of them could be. And there's a lot of concern about that for the future. There's other places like along the Northumberland Strait where they've already seen salt arriving in some the saltiness of some groundwater wells along the shoreline increasing. In some cases, that's due to things just like deposits of salt that are already there in the ground, kind of dissolving into the groundwater. So it can kind of trick people into thinking that it's seawater intrusion. But there's also places we are seeing actual seawater intrusion, particularly around the Northumberland Strait. And it's also a concern in Prince Edward Island. So it's something that is going to be a growing concern no matter what as sea level rises due to the amount of climate change we have already baked in. But it's also something that we can address by trying to mitigate climate change, but also by fighting on the other side of it, right? It's not just sea level rise that makes saltwater intrusion. It's how much we use the freshwater, groundwater resources near the coastline, as well as how we handle how that groundwater flows and not disrupting that by developing along coastlines or developing more wisely if we have to. Are there any questions about that? I know that's something that seems like it's a lot of interest for a lot of folks.
Yes, I've got a question just along those lines. It's Roland here. This is really informative. Thank you. And I was sort of thinking after all you said and done, it's the kind of the message is, well, we got to take better care of our water. Though I think there may be perception on a lot of people, like where I live, we seem to have an abundance of water. What do you think is the best way to get people to understand, you know, even people in coast areas to see, well, look, there's water everywhere, that we just have to conserve our water? What's the best messaging?
Well, not to use like too much of an overused quote, but saltwater intrusion is a great response to that kind of dismissive comment of just saying, you know, water everywhere, but not a drop to drink, right? We can have tons, we live in a humid area, right, with lots of rainfall. But even if the amount of rainfall doesn't change and people aren't necessarily over draining their local groundwater wells too much, there's still going to be some degree of increasing saltwater intrusion along most coastlines, right? So, and eventually your waters are going to become saltier. So if we don't actively do something about that or try to prevent the other things that we have more control over, like where the groundwater flows and how we allow that groundwater to recharge. If you don't move or start getting water from another source farther inland, you're going to lose your drinking water source in rural coastal areas. So again, it's not necessarily about the quantity of water, right? It's the quality, and more importantly, the quality of your particular location. So that's how I usually address that. Like, yeah, there's water everywhere, but the question is that the water you want? Is it the water that's easily accessible to you? And how much does it cost for you to get it? That brings up another really important issue. Here, I can, well, actually, I'll leave my PowerPoint going up here because I have some other slides that might be helpful for this. Another way that we can, this kind of gets at what I wanted to mention with action items. I know we're running low on time, so I can just go ahead and jump to that, mention it. But one thing that we can do in terms of how we affect this process and how we affect where that fresh groundwater is on our coastlines is not just how we control how we draw from wells. That's the big thing. That's what most people often think of is, you know, especially in areas like around the Gulf of Mexico, which is the reason I also use the Florida example and all that is because that's where I did research for 9 years and I'm familiar with the problems there. And it's a huge problem there. The overdraw of wells is the big issue that people focus on. But remember that we're talking about two things that can affect where that water table is, where that fresh water is. How much you take from it and how much it gets recharged. So if you create a lot of impermeable surfaces in your community by paving over things, and you then let any rainwater that falls on your city go into a culvert, go into a drain, and then it goes into a wastewater treatment facility and then out into a pipe into the ocean. You've just short-circuited that recharge process. So another huge thing that people can do to combat saltwater intrusion is the process of having more permeable surfaces. And if you've heard things about that, and I know EOS has done great work, there's a demo site here in Sackville of permeable pavement, right? It's something that is, when you think about what we can do in terms of actions, it's so easy. I mean, it costs slightly more, but if you think about the potential benefits relative to the cost of just, let's just not make that confining layer, an aquifer, be on the surface. Let's let those layers where groundwater won't go any deeper be deep and down below, and the ones made by nature. So another way we can make sure that we fight this balance between where seawater is pushing into our aquifers and where the aquifer is that we want to use is by letting water get there, by having permeable surfaces and using permeable pavement and not building up as many structures in areas that are key for groundwater recharge. Anything else anybody has? If not, I can mention one other big issue that I want to touch on. Any other comments or questions? Okay. One other thing that I want to mention before we roll out of here, if there aren't more questions, is talking about some of the other local issues that are worth highlighting about this. One is that when we're talking about groundwater issues, as with so many environmental issues, they are not equally distributed in terms of within our society. Within Canada, we have a disproportionate amount of groundwater contamination of groundwater and drinking water resources in rural communities that disproportionately rely on that drinking water. And this is especially true within Indigenous communities, which are farther from resources and municipal resources to be able to treat that water. We've historically put a lot of contaminating sources like certain mining activities and things that other people didn't want in their backyard near Indigenous communities. So it's important that with all these things that we're talking about, they disproportionately affect Indigenous communities and particularly other poor rural communities. So this is something that always needs to be in front of mind. It has always been a blind spot in the past for so many different environmental concerns. Is incorporating the justice component to it. And I mentioned saltwater intrusion, but there's also the issue of nutrient pollution. We have a lot of nutrients, fertilizers that get dumped onto farm fields and things like that, and add more waste, basically more fertilizer to the groundwater that will eventually make it to lakes and the ocean. And this is something that can also help drive the concerns that we have with blue-green algae blooms or cyanobacteria that do better when we add more nutrients to the water. So a lot of the problems that we have locally with blue-green algae and those blooms and toxic blooms of cyanobacteria is not just due to warming waters due to climate change, but also due to the water, that the nutrients that we put into water that seep into groundwater and eventually make it to rivers in the ocean. So this is another concern that we have here. It's not just, losing drinking water on the coastlines, but our pollution making it to lakes and rivers and causing things like this, like these, this global increase that we see in toxic blue-green algae blooms. So I'll leave it there. Again, if there's any time for any other questions, also folks can please feel free to reach out to me. My email is available on the Mount A website, but it's just Liefer, just like spelled in the flyer at mounta.org. Like I said, there's tons of information that I had that I wanted to cover, but I realized that would be way too much. So there's a lot of other things to share and talk about if folks have questions. Maybe good to have a part 2 that's more informed by people's questions. Yeah, so I'll leave it there.
Well, thank you so much, Justin. I think that really did just touch the surface of our groundwater. And I think for sure there's opportunity for more. And I know there was a lot more things that you could have talked about. So it does leave opportunity. I'm also going to I just put your email address in the chat box so people can grab it from there. And I'm also going to put in a link to a little evaluation survey that we always do for all of our workshops. So it really just takes a moment, gives us some feedback. And also if this has sort of, created a lot more questions for you guys, and you have interest in other topics of other workshops that EOS could offer, love to hear about those, because we're also going into funding application writing season, and I'm looking for new ideas and things that people want to know and learn about. So it just takes a moment to fill that evaluation form in online. But we do have another minute or two, but if people need to leave, that's perfectly okay. But we can also take a couple more questions or comments.
It's Wendy Logan here, and I am from Ontario, from farm country, Southern Ontario, and I had put in a question about, and no one ever seems to talk about it, but there is a tremendous, like mind-boggling amount of tiling has gone on, and it continues to go on. They're tiling between the tiles now and all that in huge amount of cash crop land. And I wondered what effect that has.
In what particular areas?
Well, Southern Ontario.
Locally.
I'm from Wellington County, but most of Southern Ontario now, from Georgian Bay down, is cash crop.
So, I mean, so are you asking about this as a possible solution to being able to keep?
No, the
Or as a
tiling.
problem?
Yeah, as a problem. I'm wondering, because the water is being sent elsewhere.
Yeah.
Yeah.
And so for those who might not be familiar with it, tiling is putting in some kind of surface or some kind of tubing that essentially wicks water out of the soil. So if that water isn't tightly bound within an aquifer, basically if you can make something that is more attractive to the water to stick to than the ground around it, it'll absorb into that material. So you can use that to, in some cases, it seems nice because it's a way of like trying to retain groundwater in one location. But you can also use that to essentially suck the groundwater out of one area and then carry it through that tile system to somewhere else. So, but again, that just gets at all the same basic processes. It's always good to go back to first principles with things like this, that if you are taking away from the process that's recharging a water table, and there's no decline in the losses from that, right? You're taking it from somewhere, right? We can do the math and figure out how fast something recharges based on the rainfall rate and how porous that soil is. And if you are wicking it away and taking it out of the system, it's a zero-sum game. So, yeah, I mean, that is definitely a major issue. And it's basically like throwing good money after bad, with in terms of agricultural problems, right? We overdraw water for irrigation purposes in some places, and then we do tiling to suck it even more efficiently out of one location and move it somewhere else. So it's kind of just like a sneakier form of irrigation in a way.
How would you find out about that? Because I tried Googling it and came up with absolutely nothing.
I mean, I just know about the process itself. I know it's a concern, and it creates like property battles and territorial issues and things like that. But I guess, with everything like this, the best step is looking at what are the permitting requirements, right? Like, is there any kind of permitting requirement to do this? What's the legal framework around it? And then if that exists, right, then there's usually a paper trail, right, for who's allowed to do it and who can do it where. But if there isn't, right, if it's unregulated, then that's the next step, right, is going to the politicians and those in power and saying, we think people should at least say if they're going to do this. right? And I don't know the specifics of the law around that, but that's always the first step, right? If something at least has to be visible, then it can be tracked and quantified. And then if you show people it's a problem, then you can get more people on your side too. I don't think that's a major issue in this area. Please, someone correct me if I'm wrong. Our issue is more what we put into our groundwater rather than losing it in most cases in New Brunswick.
Thank you.
Yeah. Anything else?
If I can just jump in for a quick second, I know someone who's doing their research on how the melting of permafrost is contaminating groundwater. I know that's not necessarily a local New Brunswick issue, but I was wondering if you knew anything about that and if you could speak to that. And if not, I guess it's an idea for a part 2.
Yeah, I mean, and that's a big issue. How it can contaminate, it depends on the area, but a lot of those concerns are about having areas where what's in the soil or what's near the water table hasn't been mobile. But then as permafrost melts, the water table in an area could go up. That permafrost water could go downhill, raise the water table in places that are downhill of it. And then the water table could raise up to a level where now it gets into parts of the soil that are contaminated. And that's one thing that other slides that I had I didn't get to that I realized I was like, okay, I'm not going to cover half this stuff. That's a big issue with seawater intrusion as well. We might have places where there is toxic contaminated soil, where there's some kind of industrial site near a coastline, but it's sitting there, not in the water table. And if that wedge of seawater comes and pushes in and lifts up the water table, it will lift up the water table to meet that contaminated soil. And now when your basement floods, it's flooding with whatever those contaminants that might have been in the soil around your basement. And the same thing would apply to these issues of permafrost, right? If there are places where we might have contaminants in the soil that weren't moving around the water table, permafrost melts and raises the water table, we've just brought it to the contaminants. So that's probably the biggest issue that I know, that I'm aware of with that.
Great, thank you.
And any other questions for Justin? Well, if not, then I want to thank our funders for this free webinar this afternoon. So I want to thank the New Brunswick Environmental Trust Fund. And I want to thank Dr. Liefer for your time and all this great information. And I have a feeling it might just be a jumping off point for lots more. And thank you to everyone for joining us this afternoon. Have a good rest of the day.
Thank you.